So in our last section, what we have seen, domain and range of the relation. Now today we will see types of relation and properties of relation. Whatever we are going to see, they are called as either types or properties. Both are same. So we will see one by one. The first property of the relation is called as reflexive property. Now what is reflexive? This property name reflexive comes from the word reflection. What is reflection? We used to say this term in our daily life, that I have seen my reflection. When we can see our reflection? When we see ourselves into mirror. That means mirror image of ourselves is nothing but reflection. The same term is applicable to reflexive property, that whenever you are having the mirror image of the element, then we can say that the given relation satisfies the reflexive property. Means, suppose we are having set A as 1, 2, and suppose we are having relation which contains the elements 1, 1, 2, 2, then it is called as reflexive property. Why? Because this is 1 which is element of it, and this one is mirror image of this. Means it is reflection of this particular element. Same over here. But same if I will talk about 1 and 2, it is not reflection image or mirror image. So whenever the same image or the mirror image of that element is present over there, then it is called as the reflexive property of that particular relation. This is our first property. Now, the second property is called as irreflexive property. Now, as its name implies, whenever there are no mirror image elements present, then that is called as irreflexive property. Means suppose we are having symmetric. That is, if AB belongs to R and BA belongs to R, then the value of A is equal to the value of B should be same. Means whenever the terms AB are present in the given relation, the symmetric term is present also, BA is present also in the given relation, and the value of A is exactly same as value of B, then that is called as the antisymmetric relation. Means we are having set A as A, B, C, and we are having the given relation as A, B, B. Then we will say that it is antisymmetric. Why? Because this A and this A, this B and this B, means the value of A is equal to the value of A. The value of B is equal to the value of B. And this is nothing but AB. This is nothing but AB. Okay? Same way, this is also A, B, A. This is also B, A. Means we are having the same terms. Only the value should be same. So in short, we can say that whenever the reflexive property is satisfied by the given relation, we can say that it also satisfies the antisymmetric property. Because this is nothing but AB. Because these are the terms that are present in the given relation. So you will say, is this AB? Then what is this AA? So this AA is nothing but this value of AB. The value of A is A and the value of B is A. So indirectly we can say that whenever the mirror images are present over there, it satisfies the antisymmetric property. Means whenever AB belongs to R, BA belongs to R, and the value of A is exactly same as value of B, it is called as the antisymmetric relation. Now we will see our last relation, that is sixth one, that is the transitive relation, which is basically based on the term transitions. That is transitive relation. So now what is transitive relation? If AB belongs to R, then BC belongs to R, then AC belongs to R, then it is called as the transitive term or transitive relation. So this is the transitive term. So whenever the transitive term is present in the given relation, it satisfies the transitive property. Now how you can prepare the transitive term? So we are having AB. This is our first position, this is our second position. We are having BC. This is our first position, this is our second position. Now we can see that these are the common elements. So the element which is present at the second position is the same at the first position. You will discard this and you will make the new term as AC. That is called as the transitive term. Suppose we are having 1, 3 and 3, 4. What we will do? We will discard the same term and we will prepare a new transitive term, that is 1, 4. So when this 1, 4 is present, at that time we will say that the transitive term is present, it satisfies the transitive property. Means, for example, we are having set A as 1, 2 and 3 and we are having relation as 1, 2, 2, 3 and 1, 3, then it satisfies the property of transitive. Because 1, 2, 2, 3, which term becomes 1, 3 and that is also present. So it satisfies the transitive property. So these are the types or properties of relation which we have seen today, that is reflexive, irreflexive, symmetric, asymmetric, antisymmetric and transitive. In our next section, we will see what is